Hi everybody, welcome back to the TETRIX RoboBench video series. This is Tim, and this is activity number 3 in our TETRIX PRIZM programming guide. This one is about moving your servo motors. First one, remember we did activity 1, we blinked the red light. Activity 2 was moving the DC motors, and now in activity 3 we're going to talk about and move servo motors. Before we do that, let's go ahead and make sure everybody has a refresh on what a servo motor actually is. A servo motor varies from a DC motor in that it allows us to work with position and a limited range. So a standard servo normally has a range of about 180 degrees. But the cool thing is that we can actually tell the servo motor to go to a certain position regardless of where it's starting from, and it will move to a set position. So that allows us to know where we're at. In other words, if I'm starting at, I made a mark on this servo so we kind of know, if I'm starting at 180 and I tell it to go to 90, it's going to go ahead and move in that direction till it gets to about the 90 degree position. If I'm starting at 0 and I give it the same command, I don't have to give it a different command, I just tell it to move to 90 and it's going to know where it's at and it's going to move to that position. So that's the advantage that a servo motor gives us over a DC motor. It's not as powerful, doesn't have a full 360 degree range of motion, but it allows us to track our position. So it becomes very, very useful. So, like in all our activities, let's figure out what we need to round up to do this activity. Obviously, we need our prism, we need our charge battery, we need our wiring harness so we can power on the prism, USB cable to connect to the computer, and we need a servo motor. Now, I've obviously on this servo motor, I've made a little mark so we can track position a little bit easier, but that's basically all we need. I'm going to go ahead and make my connections. I'm going to put it in servo port number 1, and I'm going to plug it in just like that. And I'm going to go ahead and connect up my USB cable, just like such, and to my computer. And I'm ready to move on to the next part of our activity, which is opening up the sketch. So I'm going to go to my Arduino software. I'm going to launch my software. If you've already got your software open and you've worked with a previous sketch and you want to save that, be sure to save that before creating this new one. If you haven't and you just open up the software, we can go to our file and examples. Again, we've talked about the best way to learn this is through examples, so we provided examples for you. So we're going to go to Getting Started, Activity 3, Move Servos. Now I'm going to do that again just so everybody can see where to find that. We're going to go to, in our software, we're going to go to File, go down to Examples, all the way down to TETRIX PRIZM, and that's where we should see all of our activities. We're choosing Getting Started, Activity 3, Move Servo. So our window should pop up here in just a minute. There it goes. I'm going to drag this so that we can see everything in one screen. Move it over here to the right. Again, just for comparison's sake, so we can see the difference between a blank window and the one that we've actually written our code in. And let's go ahead and take a minute now, like we do in all of our activities, to work on our knowledge base. So in the last activity, we talked about the comments. In this one, we want to actually explore a little bit more about the syntax of a sketch. And let's talk about the include statements and the object declarations. Now, if you look at the sketch that we opened up, right underneath the comments section, there's two little sections called include. It's got a bracket prism.h and then prism.prism underneath that. Now, the first one is our include statement. Now, an include statement, all that does is it allows us to load a library. And a library is a collection of many programs that someone has created to increase the functionality. So this is something that we actually have created here, this Prism library. We include it available for you to download, but basically it's a lot of mini programs that are going to run in the background, things like that enable the green button to be the start button each time, things like that that are meant to make it more intuitive for you to use this in the application with the hardware. So they're very, very important for you to include as each part of your program. Underneath that is the object declaration. Now, the object declaration is basically something that you will use as you begin to write more and more complicated programs. It allows you to target certain areas of your program that make it a little bit easier for you to kind of follow along and build more complicated programs. I'm going to go ahead and say right now that if you want to learn more about things like include statements and object declarations, I would encourage you to go to the Arduino website, www.arduino.cc, and look in their tutorial sections, or you could get any kind of a reference book that basically talks about the Arduino C-based language, and that will help you with a lot of these things as far as if you want to get more in depth with those. But that's something that we want to talk about because you see that in every sketch that you're going to work with. That's the include statement and the object declaration. So now that we've done that, let's go ahead and let's execute the code. Let's upload it to our Prism, and let's see this happen. So the first thing we want to do, obviously, we've checked our connections. We want to power on our board, get our blue light. We want to go to our sketch, and I can verify just to make sure my code is correct. It is. And now I'm going to go ahead and upload that. I'm going to look on my board. I should be getting my data lights, showing my data coming through. It's done with that. I should see a solid green light there. Now I'm going to go ahead, I'm going to switch hands to here so we can see what happens. I'm going to hold this, I'm going to try and execute my code. Now, based on my comments, I should see my servo rotate to 180 degrees, wait for 3 seconds, and then move to the next position. So I'm going to try this and see what happens. There it goes. Went to 180. It's waiting 3 seconds. Now it's moving all the way back to 0 and back. And it's going to continue to do that based on my comments until I press the red reset button. I'm going to do that real quick. I want to show you just one thing. Now, if you remember when we started that, I had my little dial actually about 90 degrees. When I start that again, you'll see that it'll move all the way over to 180. And then it's going to move back. So that's the benefit of a servo. It can move to that position regardless of where it starts from. So let's go ahead and talk about the new things that we added in this particular sketch. So a couple things I want to point out. In the setup section of our sketch, right in here, we've got prism.prism begins. Now that's part of that, that kind of mini library that we talked about as part of the include statement. That's going to, when we enter that, that's going to allow some of those mini programs that are running in the background to really be what we want it to be, including the green start button. So that's very important. The second item in this setup section is the prism.setServoSpeed. And in this one, we basically what the prism.setServoSpeed does is it tells the servo how fast to actually move to the position that we want. And again, there's two parameters that go with that. The first one that allows us to tell which servo we want to declare the speed for, and then the second one is then the speed that we want the servo to move at. Now, we only need to do that once. So that's why it's actually in the setup portion. So, and we'll talk more about setup versus the main loop in one of our next knowledge base in the next activity. But for now, we just know that we only need to call that one time. So that's why it's in the setup. And the last new thing that we've added with this activity is the set servo position. That's the one that allows us to talk to a servo and tell it where we want it to go. Again, two variables that we can use in that. That's the first one defines which servo we want to talk to, and the second parameter there tells it what position we want it to go to. So those are the new things in this particular sketch. We have worked with delay, so that's the same. This is duration, so that part is all just the same. So if we went into our sketch and we changed that value from 180 to 90, and we uploaded that, it should go ahead and send our data over. And when we move that to there and we execute our sketch. You see it's only going to 90, and then it's going back to 0. So I've changed where the position would be. Again, I can stop that and I can move it to this. And when it's in this position, it knows where 90 is, so it should go ahead and move to 90 just from that, even though it was in a different starting position. So that's the advantage of working with the servo, being able to move from position to position. So I hope you found that interesting. Let's go ahead and talk about moving forward from there, where the real-world connections are for this, because servos are used in lots of devices, whether it be robotic devices like in manufacturing, arms that work on assembly lines, whether it be in precise precisioning for surgical arms like the Da Vinci robot, things that actually are used in that kind of thing. Servos are used anywhere where it's important for position and precision. That's what the benefit that a servo gives us. From stem connections, there's lots of stem connections that we can talk about with this kind of thing. As far as science, we've got levers, we've got mechanical linkages, we've got transmission of forces, we've got applying torque, we've got in math, we've got arc length or radian versus Cartesian measurement. So there's a lot of different stem type connections that we can make with that. And then following up with that, like all our activities, we want to talk about hacking the code. Where are we going to go with from here? So I would encourage you, as like we always do, try and recreate that from scratch, opening up a new sketch, and see if you can duplicate what we did with our example program. Keep in mind what we've learned before. Think about the keywords as far as your syntax. Keep in mind your comments. I would also remind everybody, if you need a little help with that, in the back of the programming guide, there is our code library. Keep in mind, you can always do copy and paste, but that's there for your benefit as well. So if you need a little extra help, you can do that. But I would encourage you to try and change some of those values, see how you can get that servo to react in different places and things like that. So I think that's covered this one. So if you, again, hope you found that beneficial. Have fun out there. Build some robots. Come back and we'll do some more.